Dear student, today in this video lecture, I will discuss about different of different type of routing algorithm which is used in the network layer. Thus, so first routing algorithm of network layer discuss their distance vector routing algorithm. Now, distance vector routing algorithm operate by having each router maintain a table that is a vector, give the best known distance to each destination and which line to use to get there. These tables are updated by exchanging information with the neighbors. This is the functioning of the distance vector routing algorithm. For example, routing table for router A. First column is uh, take the information of destination, and next column is the maintain the information cost, delay or distance, and second via which router used. So we maintain the table routing table like that, this destination, cost and via. So distance vector routing algorithm was original ARPANET routing algorithm, and this algorithm was also used the internet under the name of RIP, routing information protocol, and in early version of DECnet and novel IPX. Apple Talk and Cisco router use improved distance vector protocols. So once every T milliseconds, each router sends each neighbors a list of its estimate delay to each destination. It also receives a similar list from each neighbor. This is the process of distance vector routing algorithm. For example, suppose five routers are connected to each other, R1, R2, R3, R4, I5, and distance or costs measured between the router which is assigned in a graph. So first, we create a routing table using the forwarding the message of its mapper. So R1 update the routing table like that. Destination R1 to R2, R3, R4, R5. R1 to R1 destination is 0. Next R1 is. Now next, if we approach and we reached from R1 to R2, then distance is 1 and next router is now R3, R4, R5 distance is infinite because no direct path available between R1 to R3, R1 to R4, R1 to R4. Similarly, we maintain the routing table of router R2. So router R2 direct link between R1, R5 and R3. So destination R1, R2, R3, R4, R5 like that. We reached from R2 to R1. If destination R1, the distance is 1 and next router is R1. If we send R2 to R2, distance is 0, next router R2. If we send R2 to R3, distance is 6, next router R3. If send R2 to R4, no direct path available. So we write here this distance equal to infinite and no next router. R2 to R5, distance is 3 and next router is R5. Similarly, we create the distance matrix vector R2, R3, R4, R5. And these matrix, after creating these matrix, we share in these matrix only neighbors, only distance vector. So at R1 only, at R1 only R2, at R2, R1, R3, R5, at R3, R4, R2, at R4, R3, R5, and R5 share R2, R4. At R1. So we new routing table for R1 like that. R1 only use the distance vector routing table of neighbor. Now neighbor of R1 equal to R2. R2 distance vector routing distance vector table is R1 equal to 1, R2 equal to 0, R3 equal to 6, R4 equal to infinity, R5 equal to 3. It is calculated in the previous slide. Now new routing table R1 like that. Create the new routing table R1 like that. Destination R1, R2, R3, R4, R5. Now distance calculated. R1 to R1 equal to 0. Next after R1. No change. Now R1 to R2, R1 to R2, R1 to R2 distance is equal to 1. Next after is next. R1 to R3, no direct path. So use the neighbor R2. Follow the via route R2. So R3 distance is 6 or R1 to R2 distance equal to 1. So 6 plus 1 equal to 7. As we follow R3 route via with the help of R2. Now next R1 is to R4, but R4 undefined, no direct path. R1 to R4 and R2 to R4. Therefore, the value of R4 is 80 according to this distance vector table and no next router. Now next router is equal to R5 and distance of next router equal to 3. 3 plus 1 equal to 4. We reached R5 with the help of R2. So this is the new routing table of R1. These are calculations. So how we calculate the value of this distance? Suppose R1 to R2 direct path and R2 to R2. 1 to 0. 1 plus 0. This is the R. Next R1 to R3. No direct path exists between R1 to R3. So we use R1 to R2 and R2 to R3. R1 to R2 is 1 and R2 to R3 equal to 6. So distance is calculated 7 like that. Next, similarly, we create R2, R3, R4, R5 new routing table. So here explain one again new routing table of R5. Now R5 is direct adjacent R2 and R4. So new routing table of R2, R4 like that. So R2, R4 table 1, 0, 6, infinite 3, R4 equal to infinite, infinite 2, 0, 4. So new routing table of R1 like that. R1 simple distance R1, R5 to R1 distance exists 4 and next after R2 value of R2 equal to 3 plus R2, R5 to R1 means R5 to R2 and R2 to R1. R5 to R2 value is 3, R2 to R1 value 1, so the distance equal to 4. Now next R5 to next use the R4, R5 to R4 and R4 to R1 value 4 plus infinite equal to infinite. So smallest value between them equal to 4. So we take the value of R1 distance equal to 4 next. Similarly R5 to R2, R5 to R2 and R2 to R3, R5 to R2 value of 3 and R2 to R value 0. The total calculation 3 plus 0. Now R3 to R4, 4 plus R4 to R2 infinity. So smallest value is 3. So R2 is updated by 3. Next router is R2. Similarly R5 to R3, R5 go to R2 and R2 go to R3. Value 3 plus 6 equal to 9. Yeah, R5 to R4, R4 to R3 using this table. The value 4 plus 2 6. Minimum value between them equal to 6. So take the value R5 to R3 equal to 6. Similarly, we calculate the value of R4, R5, 4, R4 and 0. So new routing table of R5. This is the process of distance vector routing. But main problem of distance vector routing protocol is this decrease in cost. Count to infinity problem. Now count to infinity problem means decrease in cost, news travel fast, and increase the cost, news travel slowly. For example, a count to infinity problem in distance vector routing. Suppose before failure of X router, These router maintain the table with the help of neighbor. So A maintain the table X distance 1 and B maintain table X 2 to A in difference of X. Now after X link is broken, after broken the router X, the X table extend infinity and we or also we maintain the table X2A. Now that X2A is provide broadcast message faster with respect to A because the cost of B is low with respect to infinity. So the value of B forward to A, the destination cost of A equal to X3B. Next, A forward the message to B and value of B is increased by 1 cost 3 plus 4 equal to updated. Now next 4 and A continuous process. This is process known as infinity process. After n number of update, A value x infinity, B value x infinity. This is count to infinity problem. The count to infinity problem is solved with the help of defining infinity. Suppose we define maximum infinite value equal to 16. So distance vector routing count cannot be used in large system with 50. And next problem solution of this problem count to infinity split horizon. Instead of flooding the table through each interface, each node send only part of its table through each interface like that. Suppose A forward the message to B and B forward the message to A. If X comma 2 comma A broadcast message A, eliminate the next row. If eliminate the next row A, then value only broadcast X to A. So system gets stable after the first update. System get stable after the first update. Next example of distance vector routing algorithm. Suppose given a graph and C is the router. We create C new routing table, estimate delay from J like that, and we create the new routing table of J. So new routing table of J direct link I, K, H, A are given. Suppose that the routing table of A is this, routing table of I is this, routing table of H this, and routing table K is this. And correspondingly, respective delay, J delay is 8, Ji delay is 10, Js delay is 12, Jk delay is 6. So, vector received from J from neighbors. So, we calculate the new routing table of J like that. If we use the destination 2, any A, we follow, we calculate the value 0 plus delay 8, 24 plus 10, 20 plus 12, 21 plus 6. So minimum value from A to minimum value J to A equal to 8. So right here the cost value 8 and follow the link, the line via A. So use the table distance table of this of A. So via A line follow A. Similarly, we raised the destination of B, J to B, 12 plus 8, 20, 36 plus 10, 31 plus 12, 28 plus 6. So minimum value is 20 from the table of A, 20 and line follow A. Now next, C. Now C destination from J, we use the table of 8, 25 plus 8 equal to 33, 18 plus 10, 28, 19 plus 12, 31, 36 plus 6. So minimum value equal to 28 from using the distance vector table of I, and the value is 28 and line follow the I. So on we calculate the new routing table of change. This is the example of distance vector routing algorithm. And distance vector count to infinity from like that. A, B, C, D, initial, all infinity are stored. Now we broadcast after one exchange the value 1, 2, 3, 4 after 4 exchange. The A comes up to the good news spread quickly. Now count to infinity from like that. Initial A is up. So after one exchange, after two exchange, after three exchange, four exchange, value is increases, and after six exchange, after n exchange, all value achieved from infinity. The concept is explained in previous slide. So count to infinity problem is should be clear. Why this news travels slowly, no router ever has value more than on one higher than minimum of all its neighbors. Gradually all the routers work their way up to infinity, but the number of exchanges required depends on the numerical value used for infinity. For this reason, it is wise to set infinity to the longest path plus one. It using hop count as metric. If the metric is time delay, there is no well-defined upper bound, so high value is needed to prevent a path with long delay from the being treated as down. Next is solution split horizon hack. Many ad hoc solutions to the counterintuitive problem have been proposed in literature. So each one more complicated and less useful than one one before it. We will describe just one them and tell why it fails. So split horizon algorithm works the same way. Distance vector routing, except the distance to x not reported on the line that packet for x are sent on. Actually, it is reported as it. So split horizon like that. When CD line goes down, it thinks it has path D through B, and B thinks it has path D through A, and A will complete. So today discuss about the distance vector routing algorithm. In the next lecture, we will discuss about linked state routing algorithm, which is the extension of distance